Monitoring systems are useful and important things. Everyone understands what they are and that they're needed. But for most people, these systems cause problems. And more often than not, engineers end up working for the monitoring system rather than monitoring helping the engineers. I'll share my experience of how it went. Probably just like with most people, at some point your boss comes to you and says that a monitoring system is absolutely essential like air. Just get it done. You're an engineer busy with your own work. Well, for example, you're configuring networks and then you get this task, set up a monitoring system. How do you set it up? Nobody has any idea how to set it up because they're hearing about this for the first time in their life. Well, okay, let's say your company has 100 remote sites, offices with communication channels to each one, and you need to at least monitor their availability. What happens at this point? You try to find some free solutions, look at what exists in general, and pick one of them. Most likely, you'll choose something as simple as possible, a system that pings endpoints and shows the availability of communication channels. You install it, test it, configure it, spend your time on it, and then expect immediate results. What do you get in the end? You get this system constantly lying to you. And how does it start lying? Let's say you have two communication channels at a remote site, primary and backup, and your monitoring system tracks both of them. You're doing your regular work, occasionally checking your email, and then a message comes in saying something's wrong with a channel. You go to the remote site, look around, check everything, everything's working, everything's accessible. But wait, how did the monitoring system trigger? Well, yes, indeed. Maybe something flickered somewhere. But this had no impact whatsoever on the availability of your office or whatever you have there. So you went once like this, went twice, 3 times, maybe even 10 times, and gradually you start to realize that this monitoring system isn't useful to you because you check and everything's working. Well, yes, of course, you'll naturally find something eventually that actually needs to be reported as not working. But that's basically it. You'll still end up with at least half of your 10 alerts being false positives in the best case scenario. So the monitoring system signals problems while constantly scattering your attention. After a while, naturally, as a living person, you understand that this is difficult and tedious for you, so you put it on the back burner. Let's look at another case. Besides remote sites and communication channels to them, there's naturally equipment at the central location in the main office. There's lots of equipment there, important, necessary, and obviously critical. Naturally, besides remote sites, you also need to set up a monitoring system inside your headquarters. Fine, you configure this monitoring system for the same device availability and some of their parameters. Then something very interesting happens. When you actually have a real problem or emergency at the main office, the monitoring system doesn't help you at all, especially when it comes to network equipment. But think about it, how can it transmit any information to you if your main nodes have failed? Absolutely no way. Most likely someone will call you or shout that, hey, everything's broken here, come running to fix it. And you'll run to fix it. And as soon as you fix what was broken, the monitoring system will start working again. Naturally, you'll get over 1,000 messages in your email about everything being broken. Very useful and great, right? Next case. Let's say you realized your company needs a monitoring system and got something more advanced. Naturally, there's been a protocol developed long ago called SNMP that sends data from devices via using some pre-prepared template following this protocol to a unified center. Remote systems being monitored send memory status, CPU load, network interface data, and a whole range of other parameters that collectively help understand what's happening with the device. Let's say you install the system at your place and configure it. And naturally, we're talking about the fact that you're not a specialist and you're setting this up for the first time. And suddenly, it turns out that every device on your network starts sending information about its status. Let's say you have about 50 different devices there, and all these 50 devices are somehow always somewhere there, working incorrectly. Well, for example, some device constantly has 70% CPU load, someone has memory filled up, and so on. Overall, if you look at them individually, this is probably even a normal state. However, right after setup, with a probability close to 100%, the monitoring system will constantly tell you that there are some problems with one system or another. And each time you'll have to pay attention to it. Check that everything is generally fine and return to your usual business. Again, we encounter the same factor that you, as a person, are very unfriendly towards such messages and would like to see exclusively truthful information and really react to the monitoring system only when there's an actual problem, not see 100 messages a day from it. Gradually, all this leads to you paying much less attention to them than you should. And finally, the fourth case. Let's say you enjoyed working with the monitoring system and configured everything properly, apart from your main responsibilities. Your systems are sending correct data to the monitoring system. False alarms are minimized. Everything is wonderful and great. And then your workday ends. You go home, sit at home, watching TV on the couch, and then the monitoring system happens to, it might trigger, because an incident can happen not only when you're at work, but also when you're at home. What do you do about this? Option 1. You configure this as a message that goes to you externally. Well, for example, to messengers or some external sources. And then you'll receive this message while sitting on the couch. What do you do with this? Run to work, but your workday has ended. On the other hand, if you haven't configured such messages, or there's no way to configure such messages, it turns out that the monitoring system signals about some problems, but you'll only see them tomorrow morning when you come to work. Why would you want to see messages tomorrow morning? Time will pass. You won't be able to react to it in time. Summarizing all 4 cases, we come to a simple conclusion that monitoring systems should be configured by dedicated people who deal only with them. They should not only configure it, but constantly adjust its settings, and besides, having a system that reacts to events. There should be a response team of engineers, maybe what's called a duty shift, who could directly take actions to start countering incidents that occurred, and after that, most likely call for help from colleagues who directly work with the affected systems. Let's move from criticism to some constructive suggestion. Once I had the chance and was fortunate to meet someone who really worked with monitoring systems at a professional level. He liked them, he understood them, he had enormous experience. He told me several quite successful cases of how monitoring systems can be used for good. Let's consider the first case. There's a remote office. Inside there's a router that serves as both a gateway for all internal networks and receives external communication channels. It's necessary to configure its monitoring. How do you do this? What options are there anyway? Option: monitor the external interface communication channels. However, if you have, for example, 2 communication channels, then the failure of one of them doesn't give you understanding that the entire router has broken down. No, this doesn't work. Second option: you can monitor some internal interfaces. That doesn't work either. Why? Because you can simply reconfigure one of them, take it out of service, and that will affect the monitoring system. It doesn't work. This also doesn't give a complete picture that the router has failed. What else can we look at? For example, CPU or memory load. Again, the router might be really loaded, and this isn't a failure, but just normal router operation. And this is also not an indicator that it has failed. So what should we do then? Well, here's what you can do. Each office has a specific set of static infrastructure services. Print server, file server, DNS server, maybe mail server, something similar. Things that are constantly, actively used all the time and represent fairly stable points. Modern monitoring systems allow event correlation. What does this mean? To understand that specifically the office router isn't working, you need to correlate several events in the form of all designated objects failing within a short time period. For example, you set that in the past 15 seconds, 4 internal servers went down. This could be evidence that the router has actually broken. Well, and in combination with communication channels, which are probably already being monitored anyway. This way, several events in a short time immediately give reason to involve an engineer and suspect the device itself has failed. Second case, my absolute favorite. How a monitoring system allows not only saving engineers physical effort, but also saves money for the company. The person who told me this worked at a bank. In a bank, As you know, there's a huge number of customer service offices, ATMs, and other remote locations. All this variety connects to the central unified office via communication channels. Communication channels are purchased for convenience from a single operator who can cover all the needed territory, and naturally, a contract is signed. The contract specifies a certain service level agreement for all communication channels. In simple terms, all communication channels should work around the clock, without interruption. Great. Everyone agreed on this. The contract is signed. Communication channels are provided. Naturally, when you have a huge number of locations, for various reasons, the telecom operator has some problem. Here and there, failures occur and channels go down. So, what did the monitoring system do? First, it automatically created a ticket template for the telecom operator when a communication channel failed. The ticket went to the duty engineer, and all he had to do was press the send message button. After that, the ticket was delivered to the telecom operator via email. It immediately included the contract number, the location where the failure occurred, time, and other parameters. Second, what the monitoring system allowed was compiling statistics of all these tickets and generating a report at the end of the month, which showed both the total downtime of all communication channels and specific incidents with time and other parameters. As a result, this allowed quite substantial savings for the company. Moreover, for the company this was a win-win situation. First, if there were no failures, it meant the telecom operator was properly performing its functions and ensuring full availability, which is what the bank needed. In the second case, if the operator wasn't fulfilling its obligation, then the company saved money, summing up everything said above. A monitoring system is complex, important, interesting, and useful. However, trusting its setup to just engineers who deal with other systems is incorrect. Besides needing a special dedicated person who would deal specifically with the monitoring system, who would understand processes throughout the entire company and constantly try to optimize the monitoring system. You also need people who will respond to events that occur. This should be either a duty shift or some specially designated people. If you take a comprehensive approach to the monitoring system, it will definitely serve your company well and make your life as an engineer much easier and more interesting.